Guys, tonight we're doing another follow-up video on this whole business of averaging and whether or not you can average quantities that might occur in some real-time event into time and space where they never exist, such as, heat and energy. Can you average heat and energy and temperature into time and space where they never exist and dilute those values and still get reasonable physics as a result of that? So someone had a really great comment that they had originally posted apparently at What's Up With That, and then they forwarded it to me. And so let's take a look at this comment here from Leitmotif. He says this is the old 4 weak suns argument. So what he's talking about there is obviously how they divide the solar flux by a factor of 4, such as to spread how climate science, climate physics, spreads the solar flux, the solar energy, the incoming solar energy per second input over the entire surface area of the Earth at once, which requires the factor of 4. So that's basically putting 4 weak suns surrounding all around the Earth instead of one strong sun on one side of the Earth, right? So he's calling it the 4 weak suns argument. Divide the solar power radiated by the sun by 4 and expecting the result to make any sense, right? So he's saying, he's saying that doesn't make any sense. So his example now is we have a pig roasting on a spit, cooking on a fire below. We divide the power radiated by the fire by 4 and create 4 equal power sources of the power divided by 4. And of course, 4 of them added up together then equal the original P, supposedly, and place them around the pig, having removed the original strong full source. Stop the pig rotating and wait for the pig to cook. How long will it take? So he says dividing, subtracting, adding fluxes and equating them to temperatures, doing all this that they do, dividing the flux by 4 is meaningless. And then his comment here is it's like saying the average person has 1 testicle. So these people, these climate scientists would say, well, that is true. The average person does have 1 testicle. That is true. That is a real, they would say, yes, that's a real physical thing. They would say that is a real physical thing that's physically real and physically valid, and it really makes sense that the average person has 1 testicle. So there are some averages that make sense, and there are some averages that don't actually make sense. Isn't there? There's a bit of a difference, isn't there? There's some context you actually have to apply. Averaging things out like that doesn't always make sense, right? So in this example of oh, here, look at this nice little graphic that someone made up for me. So how to roast a pig. Method A. You have 100% power coming from underneath and you have the pig on a spit. The other method that climate science says that you can do is you can have 25% of the power just from all sides, coming in at all sides, and that'll roast the pig the exact same way. Well, if you actually work out the energy, and I did this using the Stefan-Boltzmann equation and things like that, if you actually work out the energy involved, it comes out to a difference of, for example, you could have 375 degrees Fahrenheit roasting the pig from one direction, from underneath, for example, or you could have a pig being roasted at 130 Fahrenheit from all around. Now, which one is going to cook the pig? Which one is actually going to cook it? One of these is just going to make a really hot pig, but it's not actually going to cook it, is it? Now, let's actually think about an ice cube. Why not just have an ice cube at 1 degree Celsius and say that whatever 1 degree Celsius works out to for power, obviously 1 degree Celsius will certainly melt an ice cube, right? Well, it's the same thing as saying just go to minus 1 degree Celsius and wait for longer for the ice cube to melt. That actually doesn't work, does it? Physics doesn't actually work that way, does it? You could, for example, go back to this raw turkey, for example, right? You could have this raw turkey, if you can cook this raw turkey at 325 in 4 hours, then why can't you cook it at, say, 85 Fahrenheit in 20 hours or 50 hours or 100 hours? Why can't this turkey get cooked at 90 degrees Fahrenheit if you leave it for 20 days at 90 degrees Fahrenheit? Is that turkey going to cook? No, that's obviously not going to cook, right? So averaging values into time and space where they don't exist doesn't make sense. So for example, if you take their input here, this averaging that they've done over the entire surface area of the Earth at once, as I've said before, it reduces the power of sunlight to minus 18 degrees Celsius. Now, will minus 18 degrees Celsius ever, if you wait forever, will minus 18 degree heating from sunlight ever create this cumulonimbus cloud? Will it ever do it? It never, ever, ever would. You need real time hot sunshine to do that. Sunshine does this. This cloud doesn't create itself. Sunshine creates this cloud because sunshine is hot. Okay, but what's really interesting here is our old friend Roy Spencer's response to this. Now let's look at this for example. So he says, leitmotif, responding to leitmotif, he says, and yet the sunlight being intercepted by the earth does get spread over the full sphere of the earth. Is that not the oddest thing? Here's the sunlight being intercepted by the earth, the per second input, and that's the value we always use, right? Does sunlight fall on the earth like this, with the earth rotating underneath it? With per second input falling like this, while the earth rotates underneath that, as the seconds go on? Or does sunlight get spread over the entire earth with the per second input? I mean, what a strange thing to say. He says that is basic geometry. Well, isn't this the strangest thing, the things that they say? Here's the real geometry. This is the basic geometry. In the per second, with a per second input, which is the value that they divide by 4, this is the geometry which is developed. You have night and day. You have day on one side because Earth is illuminated on one side per second in every second. And then on the opposite of the side being illuminated, you have nighttime, don't you? That's the basic geometry in any given second, which is the value we use, that they use to divide by 4. Strange, isn't it strange? Watts per square meter. Well, a watt is also a joule per second. A watt is a joule per second, so it's joules per second per square meter. And the value that we use for that energy is the per second input. In any one given second, does sunlight get spread over the entire surface area of the Earth at once? Or does it look like this? Does it look like this? With the result that it's basically exactly equivalent to flat Earth physics, to flat Earth theory, and sunshine is freezing cold, and therefore the climate has to create itself. Cumulonimbus clouds need to create themselves, and according to this physics, pigs should cook themselves, even though they're just sitting there at 100 degrees Fahrenheit, and turkeys should be able to cook themselves by some mechanism that you can call the greenhouse effect for some strange reason, even though it's not the greenhouse effect. What strange things are happening on this world? Averages are useful metrics. Well, not always. They're not always useful, are they? Does the average person have one testicle? Is that true? Does the average person have one testicle? That is not true, right? That's not a useful metric, although it's an average. It is an average, but it's not a useful metric, is it? Does it mean anything? And just because, so Roy goes on, and just because the average temperature where you live is seldom ever actually measured, doesn't mean the average isn't a useful, the average temperature is a useful metric. Well, that's something different. Now we're talking about measured things. Yes, if you measure the temperature at your location over the day, that's because you're measuring it over the day, your local temperature at your position. You say, okay, well, the average of that was, this morning it was 10 degrees Celsius, and this afternoon it was 25, and the average was around 17 or something like that, say. Sure, that's fine. That's a bit of a metric, you can say, but that's not at all the same thing as saying that you can average the input sunlight over the entire Earth at once, because that doesn't physically exist. I mean, there are somewhat useful averages as metrics, and then some averages that don't make sense at all. You really have to understand the context. Why wouldn't context be important here? Obviously, we're doing physics here, right? Context is a little bit important. The average temperature is very different than in Fairbanks, between Miami and Fairbanks. Okay, this is just a stupid nonsense statement. No amount of nitpicking about the average temperature value almost never actually being measured. Okay, we're not talking about the same thing. It's just sophistry. Not talking about the same thing at all. That's just a stupid sophist statement. Actually, I would ask him, why is the average temperature at Fairbanks less than in Miami? Why is that? Because you know what? That should be impossible with your input that is perfectly even and perfectly averaged over the entire surface area of the Earth at once, by whence do variations in temperature arise when solar input is spread over the entire surface area of Earth at once, evenly, that it can then be represented as a flat Earth with totally uniform input across it. From whence does the difference in temperature between Fairbanks and Miami arise? It only arises because of this, because the real-time per second input is a function locally on any given surface position is a function of the zenith angle, or a function of your latitude and all those sort of things. So what's he saying? His statements contradict his own founding position here, their own founding position. Just makes no sense what these people are doing. Is that all the graphics I wanted to show you? Yeah, basically. Yeah. So, okay, that's it. I have one more example like this. Yeah, so this was, I should have introed, this is an example from the culinary arts. The culinary arts, cooking, chefs, stay-at-home wives, daddies who cook. Anyone who cooks can debunk the greenhouse effect of climate change and therefore debunk climate alarm and debunk the field of climate physics and climate science itself, and can expose science and the scientific method for being empty of character, for professing to be something, truth that they're not actually for. They can't actually tell the difference between these two figures. They think that this is totally normal. They think that averaging sunlight over the entire surface area of the Earth at once in such a way that it is effectively, logically, physically equivalent to flat Earth theory, where you have no day and night, they think that's better, a better condition, a better setup, a better starting point for your physics than having said real-time input spread on the Earth as it actually does with day and night and with hot sunshine that can actually create cumulonimbus clouds. I mean, this is just crazy. Aren't these crazy statements that these people are making? In the basis of climate physics, at the basis of climate science, they have a scheme where the climate creates itself, because the sun, they figure, is not powerful enough to create cumulonimbus clouds, for example, because sunshine is only minus 18 degrees Celsius. That's the starting point of climate physics, of climate theory, of climate science. It is the paradigm. It's the overarching paradigm through which all subsequent research and all subsequent interpretations about climate are then made. So what does that tell you about all of the research and all the conclusions and things that they're doing? What does it tell you about the nature of those things? It tells you that they are all likewise flawed because they're all based in this false, meaningless, like blatantly on its face, meaningless paradigm of equivalency to flat Earth theory, because they divide solar heat, which is quite warm, by 4, making it quite cold on paper, and then wondering why we can have warmer temperatures if solar heat is so cold. So then they say that the climate must create itself to make itself hotter. These are crazy things, people. These are crazy ideas. Normal people recognize this as crazy ideas, but you know who doesn't recognize this as crazy? PhDs in physics. PhDs in physics. People who literally even have taught thermodynamics as part of their physics career as a PhD at a university think it's entirely normal to do this. And when they see this, they don't get it, they don't understand it, and they simply reject it. They reject, PhDs in physics reject that the sun can heat the Earth to anything hotter than minus 18 degrees Celsius. It's amazing. All right, so I hope that was a little bit useful. It was quick, I think. 15 minutes. Okay, that's all right. I'm going to do one more follow-up that's similar to this. And then we're going to start talking about a little bit more theory that I've been wanting to do. Some people have actually had some questions of things that they wanted me to cover, so I'll get to that. So take care. Have a good night.